Hello everyone, my name is B. Om Charantej. I am from CACD section. Today my topic is Principle and Application of NMR Spectroscopy. Subject name Chemistry. Introduction to NMR Spectroscopy. NMR stands for Nuclear Magnetic Resonance, a powerful analytical technique. It is utilized for determining the structure of organic compounds and biomolecules. NMR explores the magnetic properties of certain atomic nuclei when placed in a magnetic field. NMR spectroscopy design. Basic principle of NMR. NMR involves the absorption of radio frequency radiation by nuclei in a magnetic field. The most common nuclei studied are hydrogen -1 into 1H and carbon 13C. Nuclei resonate at specific frequencies depending on the strength of the magnetic field and their chemical environment. Spin-spin coupling. Spin-spin coupling or J coupling reveals information about neighboring nuclei. It results in the splitting of NMR signals, providing insights into molecular connectivity. The pattern of splitting can help deduce the number of neighboring hydrogen atoms. Spin-spin coupling. The magnetic interaction between the spin of neighboring non-equivalent NMR active nuclei may cause a swelling of NMR spectrum, which is known as spin-spin coupling. The splitting pattern is related to the number of equivalent H atom at the nearby nuclei. Example 1, 1, 2 tribromethane. NMR spectroscopy techniques. There are various NMR techniques including 1H NMR, 13C NMR and 2D NMR. Each technique has its own applications depending on the complexity of the sample. 2D NMR techniques like COSY and HSQC help elucidate complex molecular structures. Again, proteins based on chemical shift, splitting and coupling determine number of protons attached to each carbon, assign carbons which attached protons, assign remaining carbons and protons based on multiple bond coupling. Applications in organic chemistry. NMR is essential for identifying and characterizing organic compounds. It helps determine the purity and structure of synthesized molecules. Chemists use NMR to study reaction mechanisms and monitor chemicals reaction. Essential practical NMR for organic chemistry. Applications in biochemistry. In biochemistry, NMR is used to study the structures of proteins and nucleic acids. It provides information about molecular dynamics and interactions in solution. NMR can also be employed to analyze metabolites in biological samples. General applications of NMR spectroscopy. NMR is used in biology to study the biofluids, cells, perfused organs, and biomacromolecules such as nucleic acids, DNA, RNA, carbohydrates, proteins, and peptides, and also laboratory studies in biochemistry. NMR is used in physics and physical chemistry to study high pressure diffusion, liquid crystals, liquid crystal solutions, membranes, rigid solids. NMR is used in food science. Advantages of NMR spectroscopy. NMR is a non-destructive technique preserving the sample for further analysis. It provides detailed information about molecular structures without the need for derivatization. The technique can analyze samples in various states, including solids, liquids, and gels. Advantages of NMR spectroscopy. A considerable amount of information can be obtained from a single analysis. The technique is non-destructive. Replicative analysis may be performed. Precious samples may be recovered. Limitations of NMR spectroscopy. NMR can be time consuming and requires a significant amount of sample preparation. The sensitivity of NMR is generally lower compared to techniques like mass, mass spectrometry. Certain nuclei may have low natural abundance, making their observation challenge. Thank you. Thank you for given opportunity.